Good. Let's make a start on chapter 15, which is graphic techniques. Today we'll look at 15a, which is sketching the graph of reciprocal functions. Your function will be continuous, defined as y equals f of x. We're going to look at graphing the reciprocal. There's a few things that you need to considerate instead of to help you to graph it in a quicker manner. When you have the first one, when you have an x-axis intercept at x equals a, the y value is going to be 0. If you look at its reciprocal, it will become undefined. What it means is for that x value, you will get a vertical asymptote. Linking to this, if you look at when the value is approach 0, it means when you approach that x-intercepts from above or from below, you get respectively the reciprocal to be positive infinity or negative infinity. So the sign will be the same. If it's positive here, it will be a positive infinity. If it's a negative, it will be a negative infinity. There's a few things I will swap around. So if you have a local maximum and minimum at a given point, for the reciprocal, it will become the opposite. Okay. Also, if your function is increasing or decreasing, then it will become the opposite. Okay. Things that will remain the same is the sign of the function. So if the function is above the x-axis, meaning that it is positive, if you do the reciprocal, it's still going to be a positive function. The value will change, but the sign will remain the same. So positive remains a positive, a negative remains a negative. And the last one is you always have to investigate when the value approach a larger amount, so infinity, positive infinity or negative infinity, then the reciprocal will approach 0 with the same sign. So if it approaches positive infinity, which is positive, it will approach 0 from above as a positive, and if it approaches negative infinity, it's a negative value. It approaches 0 from a negative value or from below. Okay, so let's look at a simple example. You have a function which is a quadratic. It's already factorized, so that it's already simplified for you to find the intercepts, which is not the concern or the focus today. It's about being able to sketch the reciprocal. Okay, a few algebraic steps that you will need to do first, and I will comment as I overlap the two curves. Let's look at the horizontal asymptote. So when x becomes very large, so when it converges towards positive infinity as a polynomial, that's what happens. The reciprocal function will converge towards 0, either from above or below. So what it means is the line y equals 0, which is your x-axis, is a horizontal asymptote of the reciprocal function. Okay, the vertical asymptote says you look at your x-intercepts for your original function, which is x equals -1 and 1. You will have two vertical asymptote for the reciprocal function, and if you approach from the left or the right, looking at the sign, you can know that the reciprocal will be positive infinity or negative infinity. F is also a as it is a quadratic, it has a local maximum, which is or minimum, which is the turning point. Here the turning point is a minimum. The coordinates is 0, -2. You don't need to turn it into a turning point form. What you do is you look at the midpoint between the x intercepts, that gives you 0. You substitute x equals 0 into f to find the y coordinates, and we get the minimum. So when we do the reciprocal, the -2 becomes -1/2, and it will be the opposite, which is a local maximum. And here is, you have the curve. When we look at the horizontal asymptote, so look at the blue curve. So as I move towards a positive infinity, the f function is increasing towards infinity. What it means is the reciprocal in red will converge towards 0, which is the x-axis. And on the left hand side as well, as the blue curve f is increasing towards positive infinity, positive again, the reciprocal will approach the 0 value from above, or the x-axis. The vertical asymptote, from the blue curve you have your two x-intercepts that will define your vertical asymptote. From the left, the blue curve is positive, so the red curve will go towards positive infinity. On the right hand side, the blue f is negative, so the reciprocal will converge towards negative infinity. Similarly, it's going to be around x equals 1. Commenting on the turning point, this is your minimum for your function f. That will become a local maximum for your reciprocal between that interval -1 and 1. Again, it's local, okay? And in red, to summarize, that's how you graph the reciprocal function.